Hello everyone. So in this video lecture, we are going to introduce you to a very fascinating tool for developing ontology, which is called Protege. And this has been developed by the Stanford University. And I guess this is the most popular ontology development tool that is available in the semantic web community. Right. Now, this Protege is a very intuitive tool to help people to develop ontologies using the OWL specification. And apart from developing an ontology, it helps someone to reason about the created knowledge base that is comprising the ontology elements like classes, relations, and the individual. So in this particular video lecture, we are going to discover or explore different facets of Protege using 10 points. Right. Now, the specific objective of this particular lecture would be primarily to introduce different features or facets of Protege concerning ontology development, and secondly, to reinforce the OWL constructs which we have already discussed in the last few classes in a better way. So we'll be having a practical way to reinforce our understanding about the OWL constructs. Right. Now, in order to do so, we'll be taking help of a very small or tiny ontology. And this ontology concerns the domain of book and publishing, right? And in this domain, as you can see, the kind of entities that you have, they are mostly related to the book and the publishing, right? The central entity here is a book. So we are talking about book ontology, right? Now, the book is the central concept, right? And book is related to, so before going to describe this ontology, let us try to think in an ontology what we really have, right? So firstly we'll be having the classes and the hierarchy of the classes. Secondly, we have a set of properties between different classes, right? Thirdly, we have a set of individuals or entities, and these entities, they belong to at least one of the classes, right? Even if you do not define the class membership of an individual, that individual by default will belong to something called OWL thing, which is basically the top concept as per the OWL ontology specification, right? Now, as you can see that different things in this ontology has been colored differently. So the concepts, they have been colored using yellow color. So book, author, country, publisher, different genres, they are different classes or the concepts. And the object properties, and these properties, as you see, as we have discussed, this can be object property, or a property can be data type property, right? Now, you can see that we have colored these object properties as green and colored the data type properties with white, right? So a book is authored by one author, and the inverse of this authored by relation is authored, right? And one author can be influenced by other or can influence other, right? A book can be published by a publisher, and a publisher can be having a location in a country. A book might be having a genre, and this genre, they have some subgenre, right? So for example, academic, fiction, non-fiction, they are kind of subgenres in this genre category. And finally, you might be having other very finer grained classification of the genre. For example, in academic, you can be having, say, algorithm, then you can be having, say, physics, something like that, right? Now here we make certain assumptions. So one assumption we are making while we are designing this ontology is that these classes, these genre classes, these top level genre classes you see here, they are disjoint with each other. So academic class is disjoint with fiction. So the intersection of these two sets is null, right? But you can think of a design where these academic and fiction, they are not really disjoint. They may be intersect. But for the sake of example, we are taking them to be disjoint. Now, there are different data type properties. For example, the book has got a publication year, has got an award, an ISBN number, and rating. Another thing that we are assuming that this ISBN number for a given book is unique. So what does that mean? That means a book can be having at most one ISBN number. And we know by the language of OWL that we need to define this ISBN as a functional property. Functional property, right? So let us start our exploration using this concept of functional property, right? So what is the first thing that we like to discuss? The effect of defining something to be functional property. So we are demonstrating functional property, right? Now, to illustrate this, we will be taking the example of a book which is Fundamental of Semantic Web Technology, which is a kind of reference book for this particular course. So FSWT has got one ISBN. So you first think of the case of data type property. Right. The ISBN number to be something. So let's say we start with some I. So we'll be having a concrete example. So don't worry about it. And let's say at the end we have 7, right? And we have another relation coming out of this FSWT, which is basically the same relation ISBN. And it is having exactly the same thing, but we have 8 at the last digit, in the last part of this number, right? Now, if we are doing so, what will happen? So this is one case. The other case is the case of object property. And in the case of object property, let us take the example of the same book, FSWT is published by this CRC Press. And this is one URI. So this is the kind of distinction that we know that is there between data type property and the object property, where the object position of the triple would be one URI in case of object property, and object position of a triple in case of data type property would be a value, right? Now we have another relation from the same book, and it has the same label, which is say Routledge CRC space. CRC Press. Now, if we do so, what will happen? So that is what we are going to demonstrate in as the first point, right? So let us move to the Protege interface. Right. So we are in our Protege interface, and you can see in this interface that the I think the home interface or the first landing interface is saying that what are the active ontologies you are having here, and there is something called ontology IRI. So basically this is the IRI that will be used to as a prefix of whatever you are defining in your ontology, right? Now there are tabs for entities, right? And these entities, they will be concerning everything. So it can be having, say, classes, it can be having the object properties, data properties, individuals, what you can think of. But you can also look at the individual elements of the ontology in different interfaces. So for example, I can look at the kind of facets related to the classes in this interface that is being shown here, right? So let me describe this interface a little bit, right? So in the left panel, you can see here, you have the class hierarchy. So here we will be just representing the is-a relationship between the concept. And now, as we know, this owl thing is a kind of top property of every property, sorry, top class for every class. This will always be there. This is there by default. And as you are developing your ontology, it might be different cases that you infer certain portions of the hierarchy. So that is what we call in technical term the subsumption. So you have defined class, you have explicitly defined class 1 and explicitly defined class 2. But while you do inference, it might so happen class 2 can be inferred as a subclass of class 1. So that is what we call class subsumption. And that kind of inferred hierarchy can be shown here, right? And what kind of inferred hierarchy you can see that we have got owl thing and owl nothing. So owl nothing is basically the subclass of owl thing that is inferred, right? And this is kind of you are having no classes in between, you are having only thing and nothing, right? So this is where you start. Now how to create one class? So the first class that we'll be creating, that will be of course the subclass of owl thing. So you select the class for which I will be creating a subclass. So I just select the subclass symbol, add subclass symbol, and add say something called say book, right? And then say OK, right? And you can see that a new concept book has been created on the thing, right? Now you can create another sub concept here, or maybe you can create another sibling concept for this book. Say for example, I want to create a sibling concept to be say author, right? And if you do so, then you see that author has been created as a sibling, and of course it will be a subclass of owl. So that's how you create a class in Protege, right? Now after you have created a class, you can describe the class by specifying value in different facets, right? So let's take the case of author. Now I want to say that the author can be a subclass of another class. You can say that. So for example, you can define say something called person, right? So add one sibling class, person, and you want to define say author to be subclass of person. So you just click on add button beside the subclass of say add, and you can type in. So here it will get you to one class expression editor, right? Now this class expression editor can be specified, or this class expression for which this author is a subclass of can be specified in different ways. So you can select one class from the existing hierarchy. So you can see I am showing you all the elements that are there in the class hierarchy. So that is what you can do. You can create one restriction class, right? So you can create one object restriction class. So for example, uh, mm, some existential restriction or exact restriction or all values from restriction, right? Similarly, you can create some data restriction. So you can say that it has it has got say number of words. So you specify the cardinality. Also, you can type in the class expression. So we'll be doing all these things, right? So we'll be typing in a class expression, relatively complex class expression. But at this point, let us select this person to be the class for which we want to make the author to be subclass of. So you can see that as we did that, so this author has become the subclass of person. So this is what we are explicitly specifying, right? Also, you can say, so I'll not be describing everything, so you can explore on your own. I'll be just looking at some of the important things. Now you can say that whenever you create an instance inside for a class that is a member of a class, those instances will be appearing under this instance, or you can add from here, right? You can say that two classes are disjoint. For example, you want to define that this author class is disjoint with book class, right? So you say disjoint with, and you select say book to be disjoint of author, right? As you see that this book is getting to be the disjoint class of author, right? So this is how we can work with the classes and the hierarchies. Now the next thing that you can do, you can create an object property, right? And as we had this owl thing to be the top class of the um, class hierarchy. So this top object property is the top property of this object property hierarchy. Now here you can see you can do the similar thing. You just say top object property, you select that and add a new property. So for example, authored by. A book is authored by, right? Now as you say create this, now you can define many things. So you can define different characteristics of this book. So you can define this to be functional if you want. It can be inverse functional, it can be transitive, it can be symmetric, it can be asymmetric, it can be reflexive or irreflexive. You can define one property to be equivalent to another property. You can define one property to be sub-property of another property. You can define a property to be inverse of another property. You can define the domain of a property. So for example, if I say the domain of authored by is a book, right? So you just select this using the class expression editor and you want to define the range. You just, again, it will be invoking the class expression editor and you just say range to be author, right? So that's how you define, right? So there is something called super property chain, super property of chain. So this is something that is also important. So there is a point where we will be discussing this, right? So similarly, you can define data type properties, but only difference between this object and data type property would be the value, the range will be taken from the XML or in general literal domain, right? Now, as you have defined this object, property, data property, etc., the next thing is you need to define some individual. So for example, you create something like say Rabindranath Tagore. So you select the particular class for which you want to make some the instance for or individual for, and you click on this diamond button and it will get you to create the named individual. So let us let us consider Rabindranath Tagore to be the instance of author, right? Now as you have created one instance, you can make this instance to be same as another individual, right? Or you can define this individual to be different with other individual. And also you can assert some properties related to this individual, and that you can do using this property assertion tab, right? So you can see one property assertion tab. There you can define certain object properties, you can assert certain object properties. So for example, Rabindranath Tagore is author of some books, so for example, you can define that. You can also define that age of the date of birth of Rabindranath Tagore is something, so that you can do with data type property assertion. You can also negate a property assertion. It can be object property or it can be data property. For example, you can negate the fact that Rabindranath Tagore is not a British national, right? So Rabindranath Tagore has nationality UK. You can negate that, right? So these are the kind of things you can do, right? So these are the basic stuffs. And added to this, there are many other things you can do, and those things you can do with plugins. So there are different plugins that have been developed by the community. So one such plugin is DL query. So as we have mentioned that this OWL has got the mathematical background to be description logic. So you can represent OWL constructs using description logic formally, right? Now you can write whatever ontology you have created. You can query the ontology by writing something inside the query box, and that should follow the description logic language, and we will get answer to the query from the ontology, right? You can also visualize a created ontology. So there are different visualization tools. So for example, ontograph is one such a tool. Visual owl is also such a kind of tool. So if you go to say ontograph, so you can see that there are concepts represented by this rectangles, and you can, if you click on this rectangles, you can see that this author and person, they are having a hierarchy, and book is also having some hierarchy. So you can see that there are certain relationship between all these things, right? So, and you have an instance of Rabindranath Tagore under author category, right? So there is another visualization. So it is a kind of a dynamic visualization you can see, and that is what we do through VOWL or Visual OWL, right? So this is a very short and brief introduction to the interface of Protege. But as we go forward, we will try to explore more. But before moving to the points that we like to discuss, I like to talk about another important thing, facet of Protege, that is reasoner. So the only motivation or only objective with which we are creating this ontology to reason about this ontology to come up with new piece of knowledge, right? So for that you need to employ a reasoner, and there are various reasoners available to be work with Protege, right? So by default, this Hermit reasoner, this comes with Protege in a bundled manner, but you can make use of other reasoners like Pellet or Fact++ by including the corresponding plugins into your system, right? So you'll be having your own installation, and in this installation you can be having these plugins, right? So this interface is a Java-based interface. This is a kind of standalone interface here, but there is also a web interface which is called Web Protege. You can also make use of that. Most of the functionalities will be kind of parallel to whatever we have in the desktop version. And this Web Protege, this is a kind of very nice collaborative tool to create ontologies collaboratively, right? So with this short description of our Protege interfaces, so I'll discuss this ontology. I'll open the ontology, a part of the ontology that we have shown in the slide. I have created a part of this ontology, and we'll be trying to illustrate the concepts with that ontology as we go forward. So the way to load one ontology, so you go to file, and so you can open from URL, or you can open from your local drive, right? So I have already opened this earlier, so I'm going to open recent, and our OWL file would be book publisher OWL, right? So Let me load this in this current window. Now, as we see, we have got this similar kind of interface. We have just changed the ontology, and this IRI, you can see that I have changed it to ontologies book social network. So this will be acting as the prefix for everything that we define in our ontology. Now let us go to the classes, right? Now in the classes, as we have seen in the slide, the design of the ontology, we have got author, book, country, genre, and publisher. And inside genre, what we have in the top level, we have academic, fiction, non-fiction. And under academic, you have algorithms, ancient history, anthropology, mathematics, physics, programming, semantic web. Under fiction, we have biblical fiction, comedy, historical fiction, mystery, romance, science fiction. And we do not have any further subcategory of non-fiction, and we have published, right? Now let us have a look at the object properties, right? Now in the object properties, we have authored, and as we have mentioned, this authored is a inverse of authored by. So we have two properties and inverse to each other. There is something called co-author. We have not specified it. We have just mentioned it in our ontology. As we go forward, we'll specify this, right? Has genre, uh, we have defined the domain of the genre to be book and the range has genre to be book and range to be genre, right? As for influence, we have defined the domain of influence to be author and range to be author also. Now you can see this influenced can be thought of a transitive property. If someone X influences Y, Y influences Z, we can say X transitively influences Z. So in that case, we can define this property influence to be transitive property, right? So we can do that. Office location is basically connecting a publisher to be domain and range is the country. We have also defined published, and published is the inverse of published by, and the domain being publisher and range being book. Let us have a look at the data properties, right? So the data properties include award, has rating, ISBN, publication year, and you see that as these are the data properties, so you do not have any other characteristics than functional, right? So any other characteristic will require one URI in the object position, right? But for the data property, you do not have in the object position to be the URI. So that's why only functional properties are available for these data type properties, right? And what are the individuals that we are dealing with? So this Hitzler is a kind of entity which has been not been classified any of the classes. So that's why it is coming under the default class owl thing. We have got different authors like Charles Dickens, Coates, Robert Louis Stevenson, Rudolph, Vladimir Nabokov, and Jerry Smith. And if we look at different properties, which we have already defined, so really did not define anything about Charles Dickens. For Coates, we really have not defined anything. Robert Louis Stevenson, we did not define anything. Rudolph, we did not define anything. Vladimir, no. Zedi, no. So only thing that we have done is we have defined or asserted that Coates is different individual than Hitzler and Rudolph. As we do that, Rudolph will become different from Hitzler and Coates, and Zedi will become we have defined Hitzler, right? Hitzler will be different from Coates and Rudolph, right? Now, if we look at the visualization, so this is a kind of visualization we can see that we have the book, and this is the kind of data type properties. These are the object properties, and this has got genre, and genre has got different subclasses, as you can see. So this is a very small ontology, right? So with this description, let us go back to the point that we are discussing, and then we'll be coming back here again. So this is what we were discussing, the functional property, the case of functional property. One is the case of data type property, other is the case of object type property. So we'll be picking up the book FSWT, we'll be asserting the ISBN number, and we'll be having two ISBN numbers for this book, and we'll be having two publishers for this book. And of course we'll be defining the published by to be functional property also. So in this case, this ISBN we have defined to be functional and published by to be functional, right? Now let us move to the Protege interface. Now in the Protege interface, so the first thing that we'll be doing, so you go to the individuals tab and you look for the FSWT. FSWT comes under book, select books, right? So we haven't defined the books, described the books. We have got many books in the catalog, like say A Christmas Carol, FSWT, Great Expectations, Impossible Book, Linear Algebra, Methods in Algorithmic Analysis, and so on and so forth, right? Now what we know about FSWT, which we have already asserted, that it has got genre to be semantic web, right? And it is published by Routledge CRC Press and authored by Quetz, authored by Hitler, and authored by Rudolph, right? And also, this is what we know, that the ISBN number of this particular book is this. So something then followed by that is 5, right? Now let us see whether we have defined this ISBN to be functional. So we have defined ISBN to be functional, right? Now let us add another data property assertion following the graph that we have drawn in the slide, right? So in order to do that, we need to select the property like ISBN, and the type would be string, selecting string, and let us put some value, say 9564. Then we are just having some fictitious number to be the ISBN number, say 2, right? Now we have kind of model is according to the graph that we have seen. What we will be doing now? We will be invoking the reasoner. We will be invoking the reasoner. So we have this, okay. Let's save it, okay. So we'll be invoking the reasoner by going to the reasoner tab and say start reasoner. Now as we start reasoner, you can see that it is throwing up an error message that inconsistent ontology exception cannot do reasoning with inconsistent ontology. And what it is saying, the reason is this FSWT has more than one value for functional property ISBN, right? So you see that it has thrown an error which is saying that this is an inconsistent ontology. So how do we make it consistent? We just need to delete the ISBN, one of the ISBN numbers. So let us delete one assertion related to one ISBN number. If we do that, and again, if we just try to invoke the reasoner, now as the reasoner is already running, we just need to say synchronized reasoner. If we do synchronized reasoner, we do not have any such problem in the ontology, right? Now let us get to the other part where this book has been published by CRC Press, and also this is published by Routledge CRC Press, right? So what I'm talking about, so say you have publisher and going to CRC Press. So CRC Press, we have explicitly mentioned that it has published FSWT. Now the other thing that we are kind of inferring uh, the other thing that we are kind of inferring is that uh, mm, that if we go to FSWT, that it is published by CRC Press, because we have defined this published by to be the inverse property of published, right? Now we have the case where it is being published by two individuals, Routledge CRC Press and published by CRC Press. Now let us try to make this property to be functional. So let us make what was the thing, published by. So let us make this published by property to be functional, right? Now, ideally, if we look at the previous case, there should be one inconsistency in the ontology, right? Because though we have defined this published by to be individual, to be functional, so that means we cannot have two publisher for the same book, but that is exactly what is happening, right? Now, this is where we have the difference between some object property that has been defined to be functional with respect to some property, data type property that has been defined to be functional. So in case of object property that has been defined to be functional, you have always the way to assert the fact that the two objects that are connected to this subject by this published by relation, they can be same individual, right? So they can be same individual, and if they are same individual, you can collapse them together and try to make the ontology consistent. And what you do basically, you say Routledge CRC Press is same as CRC Press. Let us see whether we have this kind of inference in our ontology or not. So let us go to the publisher tag, then go to CRC Press, and you see that there is something that has been asserted by the reasoner, that the CRC Press is same individual as at Routledge CRC Press. Now, whatever you are defining explicitly, they will be coming in a bold font. So what we can see here, published FSWT is coming in a bold format, bold font. So, and it is not colored, it is not having any background color. So this is a kind of explicitly mentioned assertion, explicitly asserted fact. But the other thing, like published methods in algorithmic analysis, so this has been obtained by inference, right? Now you can ask the reasoner to explain why you have got this inference. So for that, you just need to click on this question mark beside this assertion. So if you click on this, it will show how it has arrived to this particular inference. So it is saying that you have defined published to be inverse of published by, and you have asserted the fact that methods in algorithmic analysis is published by CRC Press, and that means that CRC Press has published this methods in algorithmic analysis. So this is a kind of inferred triple, right? Now this is also an inferred triple which this reasoner has inferred that this CRC Press is same individual as Routledge CRC Press to make the ontology consistent, right? Now, what will happen if I say explicitly that the CRC Press is disjoint or different individual than the Routledge CRC Press? So let us find, okay, you have got the Routledge CRC Press. So if you do that, now you synchronize the reasoner. So your ontology becomes again inconsistent because you have defined this Routledge CRC Press to be different than CRC Press, and that makes two values for the ISBN property, and you are having duplicate, like say you have the CRC Press as and Routledge CRC Press, they are coming to be the value for the property published by, right, for the same individual, same subject. So that's why your ontology is becoming inconsistent, right? So there are two ways to resolve this. Either you remove this different individual restriction. If you do that, then you will infer that this CRC press is same as routelet CRC press. Or what you can do, you can say that this published by is not a functional property. So if you do so, then if you invoke the reasoner or synchronize the reasoner, so you see you do not have any such inconsistency, right? So let us revert back to our original thing. So uh, let us go to the book FSWT and remove this routelet CRC press, because we know that this has been published by CRC press. And again, you just need to synchronize the reasoner as you have changed your ontology, right? Now let us get back to the discussion in the slide and try to reflect what we have just discussed. So what you can see here, what we did really. So we cannot do anything here really. So we cannot just say that these two values are same. So we cannot say these as same as this, right? So if you do not have the capacity to do that in any way, so your ontology will be inconsistent. And for the object property, there are two cases. One case is that you define CRC press to be same as routelet CRC press, right? So in that case, your ontology is consistent. And as we are following an open world assumption, this will be automatically inferred to make your ontology consistent, right? But if you explicitly say that CRC press is different with routelet CRC press, then you have one inconsistent ontology, right? So I think let us stop here today. In the next video lecture, we will be starting with the concept of equivalent classes and how do we model equivalent classes in Protege, and what are the kind of implications we can have in terms of inference. Thank you very much.